So after the analysis has been done, the first thing I will check is the status file, which is the file with the extension STA. So looking at this file, this is the load proportionality factor, which tells me how much load has been applied to the structure. If you remember from the previous lecture, we talked about the lambda parameter. This is the lambda parameter in a Rick's method, or in a line arc method, as we talked about it last lecture. So this shows that the critical stress of 1 that we applied, actually the force applied at the end after 100 increments is about 1580. So clearly the structure has not buckled. But let's look at the results. So I'm going to open the ODB file, and the first thing I'm going to look at is the deformation. So looking at the deformed shape, it clearly has not buckled. So since the geometry was perfect, or perfectly rectangular, and the load was was perfectly symmetric, the structure shows no signs of buckling. And if we look at the stresses, I'm going to look at the von Mises stresses, contour. It's 1.197 times 10 power 3, which is the maximum, the ultimate stress of the material. So basically, this column or this plate has been compressed up to the ultimate stress without reaching any buckling. And of course, physically, this is not possible. So let's see how this will change when we change the initial geometry.